are going to examine three closely related patterns for modeling part-whole relationship, that are association, aggregation, and composition. These determine how objects connect and are crucially their lifetime and ownerships relate with each other. So let's start with a broader concept, that is association. It's about uses a relationship. Association simply means that one object knows about or uses another. There is no ownership implied, either the object can be created or destroyed independently. There is no ownership implied, any of the object can be created or destroyed independently. For example, consider an example with a teacher and a student class. So a teacher can teach many students and a student can have many teachers. Next, aggregation. Aggregation implies ownership conceptually, but the parts can outlive the whole, often modeled with the whole holding pointers to externally owned parts. In aggregation, we have a has a relationship but with independent lifetime. Aggregation means whole references the parts but doesn't strictly own them. Then composition is the strongest relationship. If the whole is destroyed, parts are destroyed too. Association simply means that one object knows about or uses another. There is no ownership implied, either the object can be created or destroyed independently. For example, consider an example with a teacher and a student class. So a teacher can teach many students and a student can have many teachers. Teacher only uses pointer. It doesn't control the student's lifetime. The student may be created on stack or heap elsewhere. So you use association when objects interact, but they shouldn't be managing each other. So the key point is that association is collaboration without ownership. In aggregation, we have a has a relationship but with independent lifetimes. For example, a team has players. Players can belong to different teams over the time and can exist if the team is deleted. So the team stores players pointers. These are non-knowing. Whoever created the player manages its lifetime. Deleting a team will not delete the player object because they continue to exist. That is where aggregation comes in. Key point is that aggregation means whole references the parts but doesn't strictly own them. So in this example that I just discussed, the team is a whole and player is a part. Then composition is the strongest relationship. If the whole is destroyed, parts are destroyed too. For example, a house composed of rooms. So rooms do not make sense without the house that contains them. So this is a composition relationship. House stores the room objects by value. That means house destructs room instances itself. When the house is destroyed, its rooms vector is destroyed also, and each room destructor runs. So parts cannot exist independently. So in object-oriented programming, when we say that the two classes are related, it usually means one of the two things. Either one class contains another class as a data member, meaning an object of one class exists inside the other, or the one class uses object of another class as a parameter or a return type in its functions. So these are the two main ways relationships are implemented in C++. Either through composition or aggregation, that is the has a relationship that we just discussed, or interaction through methods, that is the simple association concept. So if a class A has an object B as a data member, for example, engine class and a car class, and in car class, car has an engine. So we created an object of engine as its data member. Then car and engine are in a part-whole relationship. The nature of that relationship, whether it is composition or aggregation, depends on how the part is created and destroyed. So now that we have learned the basic difference between the association, aggregation, composition, let's dive deeper into lifetime or life or death relationships between the objects. We will explore when parts are created and destroyed, who owns whom, what makes a relationship a true composition or an aggregation. So let's start with the composition, the strongest form of ownership. In composition relationship, part is literally a part of the whole. The part cannot belong to more than one whole, and part's lifetime is managed entirely by the whole. So this is very important. When the whole dies, the part dies also. This is why composition is often called death relationship. A great real world example is a person and their heart. Heart belongs to exactly one person. So when a person dies, their heart also ceases to function as they are part of that person. So the person's body controls the creation and destruction of the heart, just as an object controlled its component parts in C++. So let's walk through this code. The heart class has simple messages in its constructor and destructor. Person class contains a heart object directly by value. This means a person who owns its heart. When we run this program, the heart is automatically created when the person is created. Person calls heart.beat, showing a normal use. When a person object P goes out of scope or it is destroyed, then the heart also dies automatically. The destructor order shows this clearly. First the person is destroyed, then the composed heart is destroyed. So this perfectly demonstrates a composition, a one-to-one ownership, a shared lifetime, and a part's destruction depending on the whole. Now let's look at aggregation. An aggregation is still a part-whole relationship, but with a looser coupling, you can say, not a strict one as we have seen in composition. So in aggregation, the part belongs to the whole, but it's not owned by the whole. This is important. The parts although belongs to the whole, but is not owned by it. The part can be shared between several whole objects, and most importantly, the whole is not responsible for creating and destroying the part. In short, aggregation is just like saying, I use you, but I don't own you. A perfect example is a student and department class. A student can belong to one or more departments, like computer science, mathematics. If one department is closed, the student still exists and can belong to another department. So now let's examine this aggregation example. The student class represents individual students. The department class holds pointer to the student object, but it doesn't own them. Notice how a department doesn't create or delete any student object. In main, we create two students, Alice and Bob. Then we create two departments, computer science and mathematics. Alice is added to both departments, showing that a single student object can belong to more than one department at once. Each department just keeps a reference or a pointer to the student. It doesn't manage their lifetime. So if a department was deleted, the student would still exist unaffected, and that is the aggregation. So the depth depends on how you have implemented it. Maybe if you have implemented it like in destructor of whole, you are also controlling the lifetime of the part, then it's composition. And maybe in the similar scenario, but you have implemented it in a way that in the destructor of the whole, you are not controlling the lifetime of a part, then it's maybe an aggregation. So that entirely depends how you implement your lifetime, especially the lifetime, as I've already discussed, the lifetime is controlled by the constructor and destructors. So that is the core idea. That is how you implement the destructor and constructors define whether you have implemented it as a composition or implemented it as a aggregation. So to wrap up, composition expresses total ownership, parts live and die with the whole, and aggregation expresses shared or external ownership, that is parts live independently. Thinking in terms of lifetime and responsibility helps you to design error-free system. So whenever you design classes, ask yourself, should destroying the whole destroy its parts? So your answer determines whether you are going to composition or implementing it through aggregation.